it's using for this.
Okay. Let's continue with the other training material. I will give a general introduction to this training material. It's about classification, and we want to classify. It is a somehow chemoinformatic application, and we want to classify the compounds, and for each compounds we have a different we apply the descriptor, and we have different features for each compound, and we are trying to use this feature to classify the compounds into two different classes. First one is the biodegradable compounds, and the other is non-biodegradable compounds. So it is a classification task, and we gonna apply this simple logic regression algorithm. It is a classifier, and here you can see the short description about this quantitative structure activity relationship for classify the compounds into different classes based on the biodegradation. You can upload the data using these things similar to the regression part. And first, you should use this you should use this logic regression classifier and try to build the model and learn the model based on data. And this logic regression classifier is the same as a generalized linear model we used for the regression. But here for the classification, we can again use this generalized linear model, but here we select the logistic regression instead of the linear regression method. Logistic regression is a technique for the classification, and you can see here in this hyperlink more details about this classification techniques. And again, you can predict the class using test data sets similar to the regression. In this generalized linear model, you just load the model, and then the data is the test rows, and this is the contain header when I want to predict the class labels. It is very similar to the previous part, and again, you can remove the header because the dataset contains header. But here you will use another visualization tools named plot, confusion matrix, precision, and recall, and ROC curve. So here you can see the confusion matrix. For the confusion matrix, you have a true class labels and predicted class labels, and you see here for example, the 0 is predicted as 0 or 1 predicted as 1. It is a confusion matrix and have very important information about your classification. It is popular to use for the classification tasks, this confusion matrix. And here you see this R precision, recall, and F1 score. I define this precision, but what does mean, and this recall measure. And also this is a very famous measure for comparing different machine learning techniques. It is a receiver operating characteristics, or ROC curve, and area under curve, or AUC curve. And you can see here the result of this AUC curve and the AUC curve. For example, in this case, it is 0.94, and for the best algorithm and ideal classifier, it should be 1, and higher is the better. It is the area of the curve here between these two lines. So, and the other one is the k nearest neighbors. In the k nearest neighbors, depend on the k, we find the k nearest neighbor for the sample, and the majority of the class between these k nearest neighbors are the label for the class for the unseen data. So we can use this algorithm for the classification, and again, we can visualize the result, ROC curve, and support vector machines. It can be used for applying some kernel methods in the classification. I won't go to the details, but there is a short introduction to support vector machine with the link to the more details introduction. And I will have a sample here, how you can tune the parameters. And random forest is the ensemble method. Look like a gradient boosting method. It's the random forest is the ensemble of decision trees, and each decision tree classify the data into one class, and in random forest, based on the majority of the classes for each of these decision tree, we can find the best class for it. So in ensemble method, this tool have been used before. You just select an ensemble method as a random forest classifier, and the others, again, the tabular data, train rows, and so on. And at the last step, you can use again the data processing pipeline, with this creating the pipeline and hyperparameter search. And here you can see that, yeah, we are going to find the number of estimator between these classes, and the best estimator can be found with this hyperparameter optimization. And again, we can use this curves to see, and with the best hyperparameter optimization here, you see that we can receive the AUC curve equal to 1, and without any error, we can classify the data. So, but if you want to use this shared histories here, you can see for the classification, for each of the step, I have the history. So I recommend that you start to do yourself the steps, and when you face problem, go to that step. For example, if you have problem in this train k nearest neighbor model, you can import the history. This link is here, and it is the classification history until this k nearest neighbor model. And here at the last step, visualize and best hyperparameters, it is the whole history. Let's see. Yeah, here I want to import it. Yeah, I just import the history, and you can see all of the steps here. These are the data. When you import the data, you can see here, yeah, it is the, these are the features, the chemical or physical property of the molecules or compounds, and it is the label for the class. One is biodegradable and 0 is non-biodegradable. These are the 1 samples and these are the 0. And I want to predict the class of a compound for the test data sets based on these different features. So I want to build a classifier because I want to classify this data into 2 classes, and these are the label for the classes. And you see the logistic regression model have been used as a simple linear model for the classification. Sorry, I don't, yeah, it is a zip file. I want to see the result here, yeah. And this is the class, predicted class based on this nonlinear. And with the confusion matrix, I can compare them. If I mean the true label is 0 and I predict 0, 508 samples categorized here. These are the true prediction, and also these 228. But I have 55 confused classification. I mean the true class label is 1, but I predict 0. It is one portion of the error. And here the true class label is 0, but I classify it as 1. So this confusion matrix have information about this classification. But these are in this area and this area are classified correctly. Yeah, for the nearest neighbor also, I build the nearest neighbor classifier with this parameters, and you can see here again the estimation using this k nearest neighbor classifier, and again the visualization and support vector machine as well, random forest, and at the end I use this ensemble method and extract the hyperparameter of the model and find the best hyperparameter, and you see the 15 estimator is the first rank. I mean the 15 decision tree in the random forest is the best, and we can reach the AUC equal to 1. It is the ideal classification. And as you see in this confusion matrix, you don't have any data that mislabels. The number of data that mislabeled in this area is 0, and also here is the 0, and it means all the data are classified correctly. If they have a true label is 0, we classify it as a 0 label, and if it is Y, we classify it as a Y. So it's makes sense that here we have AUC equal to 1. So it is for the classification. The other training material talks about unsupervised learning. It is about clustering. And the aim of this clustering in machine learning is I want to cluster these data, for example, into different categories, and I don't know the label of this data. They don't have any label. It is unsupervised. And I want to use types of different algorithms for this classification, such as a connectivity model and algorithm, centroid model, and density model. And I use some clustering distance measure I described here. And there are some approaches such as hierarchical clustering. In hierarchical clustering, you start from the samples and merge the 2 nearest samples to each other and go further until you have 1 class. And when you have the biggest line here, it is the best place to split it into the different categories. In our example, it can be divide into the 4 category, and you will have the 4 clusters, as I introduced in this background. And I use this iris data sets, and in this iris data set, I want to use different features for these different kind of iris flowers, versicolor, virginica, and setosa. I have these 4 different features for each of these: petal lengths, petal widths, and sepal lengths and widths. So you can see here how we can cluster it with the hierarchical, and here is the biggest gap, so I can cut it, this hierarchical clustering for the merging, and I have 3 different categories, and each of them demonstrate one of the type of this color. And in order to do this clustering, we use this numerical clustering tool, and here we choose the hierarchical agglomerative clustering. It is possible that you visualize this hierarchical clustering. There is another visualization tool named scatter plot with ggplot, and you can set a label for the X and Y axis and different color for each category, and you can visualize the data right here. And the other well-known algorithm for classification is K-means clustering. I described the K-means algorithm here. There are 5 steps, and in numerical clustering package, you can easily choose the K-mean for this clustering algorithm. And again, you can do the scatter plot for see the result. And the other one is the DBSCAN, density-based spatial clustering of application with noise. It is a very good clustering approach, and if you want to compare these 3 algorithms together, I apply the clustering algorithms on multiple data sets, and these multiple data sets are these 2 different data sets. One of them called moon data set and the circle data sets, and I applied the K nearest neighbor, K-means algorithm hierarchical clustering and the DBSCAN to these 2, and you can see the results here. Yeah, it is the result for the DBSCAN, and you see why DBSCAN is useful. If you use for example, the K-means algorithm, these data classified such, and it does not make sense because you have these 2 classes, not this one. But the K-means and hierarchical categorize the data into different ways, but this one is the correct one. Or if you have these moon data set, again, you see the DBSCAN is the best one. These are the weakness of the K-means and hierarchical clustering, so we go further with some advanced techniques such as DBSCAN for clustering, and again the conclusion. So here in the last part, I have the galaxy history for the clustering. If you go to the last one, oh, sorry, maybe. Okay, for example, I import for DBSCAN, for example. You can see the visualized DBSCAN here, and I used this package to create the data. This is the scatter plot with ggplot. It is the columns and plot title and label for each of them, and height and DPI of the output. And we can visualize the scan clustering data with this ggplot visualization. And it is the clustering package in here. Yeah, it's mentioned it is a newer version of this, but yeah, in this history we use the older one. You can go here and easily switch to the latest and a newer version. You see, yeah, this package, numerical clustering. If you use this numerical clustering, you can select how you can select the columns. It is same as clustering, classification and regression. But here in the clustering algorithms, there are different algorithms such as BERT, dbscan, k-means, mean shift, mini-batch k-means, affinity propagation, and hierarchical clustering. And here we use the dbscan or hierarchical clustering or k-means to cluster our data to different categories. In k-means and hierarchical clustering, especially in k-means, you should define the k. I mean, how many clusters do you think it would be, how many cluster? I mean, you should have a general overview of data, for example, and say, yeah, I think there are 3 clusters. For example, here in this tutorial, if you see the data, you can guess, yeah, I have 2 clusters, maybe, yeah, 2 clusters, and here again 2 clusters. So in the k-means clustering, you can set the k equal to 2, but in dbscan, it is a very good advantage, and no need to set the number of clusters, and it's automatically fine. So I think we are almost done with this tree. And yeah, I know in this clustering and classification, maybe you have some questions, but I will answer you. I want you first. I know it is a bit and quite a long workshop. Maybe you are tired and you are not interested to do it right now, but it's okay whenever you start to follow these tutorials yourself from the beginning and follow all these steps and reproduce the results. I'm still available in the Slack channels. Please ask me question, and it is one of the reason I created the Slack channel. Please ask question. I will help you, and if you need any more information, any detailed documents for some part of the tutorial, please tell me. I will share the materials with you, and or give you some more introduction to better understood training materials. And feel free to send us your feedback about these training materials. And as I said, I will be in the Slack channel at least for 1 week or maybe 10 days. Please, if you are interested with this machine learning pipelines in Galaxy, start to reproduce your own results following the tutorial. I'm almost done, but in the remaining time, I'm here. Feel free to ask any question. If you have any question related to your data analysis, if you have any idea, if you have any challenges, and And if you are interested to use this machine learning approach in your data analysis, please share it with me and we can discuss about it. Thank you so much. I'm here to any discussion. Okay, please. Thanks. Any question, any discussion, please?
So maybe having a bit more on your intake of how, so which parameters could be more important, like when are you done calibrating parameters? Like I know there's nothing like a perfect solution, but yeah, like what would be your first steps to do the parameter selection?
Parameter selection or feature selections?
Well, now that you mentioned features, I think both.
Because there are the difference between the parameter selection and feature selection. As you see, in feature selection, you have different or many columns, and you don't know in this prediction, in this regression part, you don't know which genes are more related to the age and which are the biomarkers. It is the other problem. And it is not an easy answer for it, but if you go here in the pipeline builder, can you see my screen?
No.
No, okay. How about now? Can you see?
Yes.
Okay, so here in this pipeline builder we used before, in the pre-processing step, there is a feature selection. So you can use the feature selection and set the algorithm you want to use to select the best features. For example, select k-best. It selects features according to the k highest scores. For each feature, it gives you the score and select the k best based on this score. And the scoring function is this one. For example, G2 or F regression or F classification. Or the other method, it can be this, for example, this one, RFE, feature ranking with recursive feature elimination. In recursive feature elimination, it eliminates one feature in each iteration and see how it affects. And based on this recursive feature elimination, tell you which feature are more important. And beside this, there are many techniques. There are also some evolutionary and iterative methods, or some approximate method, greedy methods to find these features without using expert to tell you, hey, this is the important gene, this is the important features. You can see my paper. It's published for finding the best features for classification macroarray data in two categories, in the cancer category and normal or non-cancer category, and how we can select the best genes and important genes. Did I answer your question?
Yes, that helps a lot. Thank you.
Okay, but if you need more, please tell me. And I agree with you. It is a very good question. That's feature engineering and parameter optimization is very important. And if you done it automatically, if you have an algorithm to tell you, hey, these are the best features and these are the best parameters, then you will have the automatic machine learning. We call it AutoML. It is the state of the art concept in machine learning research and how we can create an algorithm and it is automatically tuned based on the data and find the features and so on. It is the AutoML.
Thank you.
Okay, thanks for your question. Any other question? Any further question? So if you don't have question, I hope this workshop helps you in your future research, in your future data analysis. I will be very happy to help you in your project. If you need any collaboration with the machine learning parts or somebody in our team, please feel free to contact me, send me an email, and I will do my best to help you. And if you have any question related to this training materials, please feel free to ask in the Slack channels, or and I will try to answer and send you some information that helps to solve the problem.